Okay, I'm trying again about
30?
audio.
Third.
How about we order
Can you
Matt
hear
pizza?
said.
now?
Yes.
18
Yeah?
given
Hey, you know what, team?
15?
We've been here for a while.
First?
How about we order pizza?
8?
Yes.
Actually make it a month.
All right, so
Way
how do we
back
want
then.
to do this? We order like a half
Which day?
pepperoni, half cheese.
How about we get
Nine.
the full cheese?
All right, so
half
no January is
pepperoni,
amazing.
And then
Now let's
order
do
all.
February.
I
All
got
the
it.
February
One
hands up.
full olives,
Date.
just total olives, and then one really small pepperoni and 2 extra large cheese.
Or we do a whole fleet of pizzas. Half of
Matt,
those
so
pizzas
we
are
finally
half
got a
Brooklyn
match.
crust,
So we
half
got to
Chicago
February, which
crust,
I'm
and
actually
they're all
astounded
2/3 pepperoni and 1/3 cheese.
Just make sure we get one veggie pie, half cheese. That's all I ask.
Or
8 pies, hear me
people
out.
with a
On
matching
each one of
birthday,
those,
if we
okay?
have
We've got 1/8
23
cheese,
people in the
1/8
room, right,
veggie,
that's a tiny
1/8
fraction of the
stuffed
whole
cheese
calendar.
crust,
Less than
no
1/10
cheese.
of the think of.
Hey guys,
I got it.
That
One
point,
eighth
it's a
buffalo
50%
chicken,
chance
no cheese,
already.
no sauce. 1/8 sausage, 1/8
If we
thin
go up
crust,
to
Delaware
50,
style,
it's now
then
less than
1/8
3%.
totally blank. Raw
If we go
dough.
to
That's why I run into trouble with raw dough.
Guys,
10%, and we get to
we're all
80 people, we're
executives.
already down
Let's
to
just make an
1/100.
executive decision here.
Right? So in this room,
Eight
was
people
guaranteed with
But with
150
veggie crust.
people, it
And
turns
no
out it's
sausage,
roughly about
full onion.
1.
Extra onions.
Okay.
Sort of
So I
funny,
was
right?
almost willing to put money on it, but there's still a non-zero chance.
Guys, it'll be
And
really
so I was
difficult
like,
to do the
okay,
class if
there's a
nobody's
small chance it could.
responding.
I actually got worried when we got through January. So it's somewhat counterintuitive that this would be the case, but it turns out if you look at
Guys,
the problem
hear
more
me?
closely, it's not that counterintuitive at all. And the reason is here's the first person they pick
Yeah,
a birthday.
but
Here's the
I
next
think
person
your
they pick a birthday, and we compare
lecture
them.
is still going
Then
on,
when
so
we
I
have
can't
the
hear
next
your
person,
voice.
we compare them to both of you.
What is
And
still
the
going
next
on?
person, we compare them to the 3.
Oh. Could you hear the video?
Yeah, we could hear the video.
That was clear, right?
Yeah.
Okay, cool. Okay, so let's begin today's session, whatever it is. And we can discuss more things, talk about decision making. Let's make it more relevant, right? What did we see in the video lecture that you guys saw yesterday? And I personally love that lecture because the professor discusses everything that's really relevant to decision making, right? And decision theory, right? Right from probability and what are conditions or factors which impact probability. He says that you can't while you're supposed to take rational decisions for everything, you can't be doing a calculation for who to marry and who to not. And those are situations where all of these things aren't meant to happen. And probabilities are also very contingent upon the factors in which they occur, right? And there are other factors rather than just the mathematics of certain scenarios. So you mix belief and you mix mathematics to ensure that you're taking decisions that you do take, whether they're rational, irrational. I mean, I personally feel that we have to be the judge of that, but this is where mathematics comes in, right? And why was that video important? It gives you an entry into conditional probability. It also gives you an entry into how you're using mathematics to talk about expected utility. Okay, and expected utility is something I'll touch upon today because we've spoken about utility, right, in the first class, and we've spoken about maximizing utility. But now what we do is we start bringing in the human factor. We start saying that probability is subjective, that your utility that you're deriving from certain things is very subjective in nature. All right, what is your expected utility that you think will be derived from certain things? And which is why in the end he uses examples which are like, would you choose a certain 10,000, or would you take a bet on 20,000 or zero, right? Why does he do that, right? And what are conditions under which he's doing that? So the probability and the mechanics of that probability is what we refer to as subjective probability. Okay, and subjective utility theories. So it's a part of expected utility theory where you're not assigning values based on some generalized conception or generalized idea of what the utility is that you're deriving from a particular object, but you're providing your own values of what is the utility or the satisfaction that you're deriving from a particular thing or a particular choice. Okay, but let's talk about this scenario, right? 20,000 versus zero. and or the other option is don't play the game and you get a straight 10,000. What are factors impacting this? Or if you, since we've expected everyone to have seen the lecture that was shared yesterday, what are factors, or what is the situation or the place set in which we are taking this decision? You can just unmute and answer. Anyone?
I think I would consider the probability of like winning the game compared to like, yeah, like the risks involved compared to like settling for the bare amount that you can get without playing.
So you would have done the probability rather than choosing the 10,000?
Yeah, I would, because I mean it's like kind of a big prize, right? So I guess it would be worth it to do like some simple calculations and then estimate like whether it's worth it or not to give up the 10,000.
That's fair. And I think that's one of the most calculated or rational answers in economics, as I would say, that I've personally got for this question, right? And what does the professor talk about of what is the general scenario if, let's say, you didn't know that we're actually talking about decision making and decision theory and probability? In those circumstances where you're in, let's say, a situation and you have to take an instant decision, would you actually do this mechanics, right? And what theory says is, and obviously this is based on experiments and observations that are still developing in a very fast way, right? And these concepts and our understanding of these concepts are evolving. But what theory currently says is there are two scenarios in which these decisions are taken. So it's known as decision making under risk and decision making under uncertainty. What do we understand by risk, and how do you think it differs from uncertainty? Anyone, what is your intuitive understanding of risk and intuitive understanding of uncertainty and how they differ from each other?
Yeah,
I think, oh no, go ahead, go ahead. Um, can I speak, or was Julia going to
Yeah.
talk?
Go ahead, go ahead.
Okay. I think in risk, you know the factors that are going to affect your decision.
Mhm.
So you make so in that case, risk means it either is a high road or is a no road, or you can be, in the middle, neutral. I think uncertainty is you make the decision without knowing your factors.
Exactly, absolutely right. Julia, do you want to add on something to that?
Yeah, I was just basically just gonna say like uncertainty is when there's like an element of but like you can't really determine, like there's no like concrete answer. Uncertainty is like, oh yeah, 100% I'm gonna get this.
Yeah. And what about risk?
Risk is like, I think risk is basically just like how there's like a yes and a no, like I guess in psychology it's like there's good and bad to like a certain out like a certain procedure, and then you can just like, I don't know, you can just like play the game or just settle for safety. Yeah.
I think those are great definitions to get, right? And I'm so glad that you said settle for safety, because that's something we're going to talk about. And that's exactly why people choose the 10,000, right? Or wherever, behavioral economists, and they've done these experiments with a large set of people, why a huge majority of people have chosen to take a sure 10,000 rather than to bet on 20,000 versus zero. Even if the probability of the utility that you're getting in monetary terms is 10,000 in both scenarios, right? And why do people do that? Exactly for this reason, for safety, for certainty, that as human beings we prefer certainty over uncertainty, and um, we're risk averse in certain situations and we're risk seeking in other situations. So this attribute, risk averse and risk seeking, this is also something we'll discuss really in depth when we go on and talk about behavioral economics. We talk about loss aversion, which is one of the biggest things that have come up in behavioral economics. But also, why is it very relevant here? Because when we're saying that you're taking decisions under risk or decisions under uncertainty, all of these components, right, where our understanding in human logic does not equal what the economic or the mathematical interpretations of certain scenarios would have been, right? So I'll move on to how, risk, like I think Shivani answered, right? How risk and uncertainty at least differ with respect to the probability calculations of it. And is that risk, you know what options you have. So let's say I know that there's a 5% risk of not getting the 20,000 or something of that sort, right? So I know the outcomes that are there. So, but I'm unsure of what might happen, but I know the likelihood of particular outcomes, right? That is what risk situations essentially become. And because you're at least aware of what the outcomes might be, getting the 20,000 or getting zero, then it becomes a risk situation, and it's something that can be quantified. You can create a model where you're providing your subject, or you're providing your respondent with these options, 20,000 or zero, or a sure 10,000. This becomes a risk scenario, and it's a risk scenario. The outcomes are unpredictable. You don't know what would happen, but you know what are possible outcomes, what are different directions that a situation could particularly become. And that's why it's called a risk situation. So this is like, why is understanding this important, that you're at least aware of outcomes but not what will happen, because you can still calculate it. And if I'm talking it from mathematical modeling, right, or economic modeling, to calculate all of these probabilities, like the professor also spoke about, it becomes important to understand what are criteria of a risk situation. Uncertainty, right? Now we've spoken about risk. Would you like to add something to your understanding of uncertainty? How do you think it's different? And if someone could give me an example of what an uncertain situation might be.
Okay, so after knowing what risk is, I think uncertainty now can be like, it's just unquantifiable, because like risk, at least you kind of knew like the probabilities. But for uncertainty, I guess you just don't have anything, and then you just, yeah. Um, so I guess a scenario, actually, thinking about it now, it's kind of hard to think of something with no probability. Um, I guess for me, like everything kind of has like a probabilistic like element to it. But I guess something in the future, like something really random, like super far from now, I guess would have like a really random like probability like chance. So yeah.
Yeah, exactly. Chance, right? And that becomes an important component again, right? And chance is something. What is chance? Should we even understand? When we're talking about chance, what is the chance of one thing other than the other? You still have probability that's happening, right? When we frame questions, well, so when you guys look at, probability questions and different scenarios that you get, there are different understanding of chance and different understanding of possibilities in the mathematical sense also. So in a chance, you're expecting things to be random in nature, right? But it still differs because you know what the outcomes can be. And in uncertainty, that even the outcomes that can be are a question mark. And I understand, Julia, and it's really cool that you can, think of probabilities or assigning probabilities in all events or all situations in your daily life, because that's definitely a skill for everyone, right? And that's what economics wants us to do. But uncertainty is exactly that. Uncertainty often cannot be modeled, but we do assume things. And that's how we've thought of, let's say, more of behavioral theories to account for uncertainty, right? So you're not even aware of, so in risk, you're aware of outcomes, but you don't know what will actually happen. So there's still a future question mark. Here, the outcomes themselves are also a question mark. You're uncertain about the future, and the future isn't predictable at this point. So this is where also something, things like historical trends is something you use to answer questions that pertain to the future when you don't know about outcomes, right? So that is where uncertainty comes in. So it's important to understand this distinction, because when you're reading literature on this, risk and uncertainty are often incorrectly used interchangeably. but the premise in which they're working is slightly different, and that can impact your understanding of it. And which is why a lot of people, Daniel Kahneman, right? Daniel Kahneman and Amos Tversky, who's meant to be who are the so-called founders of behavioral economics in the modern era. It started even before him, but they refer to as the founders in the modern era, right? The 21st century and plus. And their paper, Judgments Under Uncertainty and Risk, right, is a really important paper, and that will give you direct insight into what are what in these situations are behavioral aspects that come into place. So when you can't rely on numbers and you can't rely on mathematics, you resolve to your intuitions and you resolve to your biases, heuristics, rules of thumb. And this is where factors, like in the first class we spoke about what impacts our choice, right? Our social upbringing, our psychological understanding, our economic backgrounds, that sort of stuff. So these socioeconomic demographics have an impact on our choice and on our decision making. And so when you don't have numbers and quantifiable um, data sets to account for probabilities, you use all of these things, you use your intuition to account and take decisions in uncertainty, right? Because Julia believes that there's probability for most of the events in her life, and that's really cool. But what are situations where you're necessarily forced to take decisions under risk or decisions under uncertainty? If someone could share, um, situations they've seen in their daily life where you have to account for things without knowing what might happen. Anyone? Let's make this session more discussion based, because it's this is meant to give you a more intuitive understanding. Yesterday's lecture was already pretty heavy, looking at the entire Stanford professor's lecture.
I guess if like nobody's gonna speak. Oh, okay. Go ahead. Like if anyone else wants to go. Okay. I think that like decisions that people make, like kind of I guess like situations, right? So if you take somebody, for example, who's less like socioeconomically privileged, they would end up making like a different like something as trivial, I guess, like as stealing from a store. Like there's a risk of getting caught, but for them like the benefit kind of outweighs it because they're like hungry. But for like a rich person, they wouldn't really see the need anyway to do it, so they wouldn't like take the risk involved, I guess. Yeah.
That's a great example, right? And even then, like if the robber had like or if the burglar had an economics background, he'll probably do a cost benefit analysis of whether it's worth stealing that. And that's a really good example. Anything else? If someone else wants, yeah, Arisa. Okay. Yeah, so I'll move on to what uncertainty is, right? Exactly this. So you don't know, you can't predict the outcomes, and you don't have enough information available. So let's also talk about information, right? Because what is your understanding of scenarios that can take place, right? And information plays a huge role here as well as in generic classical economics, right? And why is that so? Because classical economics assumes that when consumers are taking decisions, you have perfect information. You have an entire idea about what are prevailing market prices. You have complete idea about what are different prices that different firms are providing you with, and then you're taking a rational decision based on all of this information that might be available. But is it but in your daily life, do you have complete information about what are different prices people are providing you with, what are different offers in different place? Do you have that complete information? And this example I'm only giving with respect to purchasing, but when we're talking about decision making, the definition or the ambit becomes even wider, right? If you're taking decisions about whether to invest in a particular stock or not, do you have complete information? You can do your research, right? You can do your research on the financials of a particular stock, of the future of the future plans of the company are. But you can't predict if next day oil prices suddenly shoot up, right? or firms in Saudi Arabia which are really dependent on oil, they can't predict if oil prices really fall, right? So in these scenarios, there's still uncertainty involved, and you can't predict these outcomes are there. So there's no value that you can provide, and therefore you also don't have complete information by the virtue of the fact that you're a human being. So you can't account for future unpredictable situations, right? So that's precisely what uncertainty is. And um, in yesterday's lecture, these are situations where probability does come into picture, right? Because when you're tossing a coin, or or you have to gamble, or you have to bet on something, you know outcomes that are there, but you don't know what outcome will come, whether the outcome will favor you or not. And those are decisions in risk, and you're using probability in those scenarios. So that's why we started with, where does probability come into place, where does mathematics come into place? And this is exactly those situations. How are stock market trends based? So the professor also talks about how there are two types of beliefs in probability, right? Bayesian and frequentist. Okay, frequentist people say, if you see something happening enough times, right, then you can predict the outcome, or you can predict if it will happen another time. But Bayes and Thomas Bayes said that you can't predict things. That what if there's something that you can't see in the future, and that's something you have to see in the past for? And that's where trends and conditional probability. I used the weather example, and I was really proud of myself because the professor also used the weather example, that you're calculating weather based on conditional probability. You're calculating weather and weather forecast on the basis of what has happened earlier in this time, in this particular situation or region. And probability is very important for that. And Bayesian probability and conditional probability is just the start of it. And it can do so much more, right? De-anonymize the Federalist Papers. Big things. And they seem very simple right now, but the theory and their understanding is really deep. So you can use it for bigger things like de-anonymizing, but you can also use it to take decisions where you don't know what values you can account for in different outcomes. All right, does that make sense? Are there any questions at this point? So then we'll move on to a fun part.
I have no doubts.
All right, great. Okay, since no one else is mentioning anything, I'll just move on to this. So I personally really love paradoxes, and I think that's also like because what are paradoxes, right? They sort of, you understand something and you understand that, okay, this is how things should work, and then paradoxes come up and they tell you that, but this is equally right. And paradoxes are completely logical, and they're truth statements that contradict themselves. So those are scenarios, right? So if you have axioms that are already accepted truths, like classical economics is supposed to be, and then you find faults in that, and they're completely logical, and you can support it with observational data, right? So it becomes paradoxes. And today we'll be covering two paradoxes that have been widely accepted in economics. And this is sort of the beginning of introducing behavioral economics and the concept of behavioral economics in traditional economics, right? Because these concepts, these paradoxes, were accepted before the theories of behavioral economics started developing. Right? The first paradox we discuss is the ally paradox. I think that's how it's pronounced. It's French, and I would not credit myself with good pronunciation on that, so I just excuse myself from it. But Ally paradox, it was founded by Maurice Ally in a paper in 1953, and the person did win the Nobel Prize in economics, right? And 1953 is much before Daniel Kahneman and Amos Tversky came into the picture, right? Which is 1970, 1980s. Okay, so much later. But this is the sort of beginning to it, because you're already beginning to find loopholes in the theories that were existing. Okay, so this has to be more interactive, right? So we have two scenarios here. You have two pills, an orange pill and a blue pill. The orange pill says you have 100% chance of living for 12 years, right? And so you've gone to the doctor and it said this situation is very grim. Here are your options. The second option is you can take the blue pill, and the blue pill gives you 10% chance of living for 18 years, 89% chance of living for 12 years, but 1% chance of sudden death. What would you, sorry, what would you choose in this scenario? Everyone has to answer here. Yeah.
I would choose the orange pill because the blue one is like 89% chance of 12 years. And then there's only like a small 10% chance of living like 18 years, and that's like not that much of a difference, and like the probability is small. So, and like there's also that like 1% chance of like sudden death, right? So I'd probably take the 12%, the orange pill, because it's like 100%, and then on the blue one it's at like 90, basically 90%. So it's like kind of almost like the same thing, you know. So yeah.
Okay, so we have Julia's answer. Who else? Everyone else has to answer so that we know, and then we can discuss your answers. Shivani?
Yeah, I was just thinking, I think I would go with the blue pill.
Okay, why?
So I think you have an 89%, I'll say 90% chance of living for 12 years. And then, so remaining again, you'll have another 10%, as compared to the orange pill. So that 10% is again giving you a chance for living in 18 years in the blue pill. And there's a 1% chance of sudden death. So I think it will be more favorable.
So the 1% death is a chance that you want to take?
Yeah, given the conditions, I think I would.
Okay. Who else do we have here? Huang?
Yes, I would choose the orange pill because it's 100% guarantee that I would live like 12 years longer. Because in the blue pill, there is, after all, that 1% chance of sudden death.
All right, great. I don't know how to pronounce this name. Madan? Or Madan? So I'll just, this is your surname, I think. Are you here? Okay, never mind. So we have two people who've chosen the orange pill and one person who's chosen the blue pill. Okay, let's keep that in mind. Here, so we have another two pills, a green pill and a purple pill. Wait a second. Oh no. So the statements aren't different here. Okay, let's just discuss it using this only. Sure. I'll send you the video to like know more about this. Okay, but basically, why did you choose the orange pill over the blue pill, even though the blue pill has, let's say, if I had to put it that way, right? The blue pill has provides you with a 99% chance of an 89% chance of 12 years, but also a 10% chance of living for 6 additional years, right? So in total, that's still a 99% chance of living, and probably even a chance of living more than the 12 years that's there. But still, out of the 3 people that did answer, 2 people chose the orange pill. And this is exactly what we were talking about earlier when we said that humans choose certainty. All right. So I don't have the second situation here, but it was modeled on the same scenario, right? And what this shows is that you will always choose certainty over situations that are uncertain, even if this might give you a greater trade-off, right? And that 1% chance of death, and that is still sufficient uncertainty for you to choose the orange pill over the blue pill. And that is the ally paradox. And you can, so we've used pills here, and there has to be a C and a D option, right? Where there's 11% chance of living for 12 years and an 80% chance of sudden death. Or wait, let me put that. Do you guys mind watching that video? I could get a yes or a no, something. Guys, you really have to answer.
I think we're okay. We're watching the video.
Yeah, we're okay.
Okay, let me introduce you to that video.
In one recruiting season alone,
Do you have
Scale
audio?
had more grads join
Yep,
Amazon
it's good.
than from all IITs combined.
Skip that.
percent chance of sudden death. So, which do you choose?
Okay. So this is the scenario we're working with, right?
12
Let's
years
see.
before dying. And the red pill would give you an 89% chance of living another 12 years, a 10% chance of living another 18 years, and a 1% chance of sudden death.
And here,
So,
in this scenario,
which do you
we've all
choose?
chosen,
Now,
2 out
remember
of 3
your
people
answer
have
and
chosen
imagine a slightly
100%
different scenario.
chance
Your
of living
regular
for 12
doctor is out that day, so you go to a slightly dodgier one next door who offers you 2 treatments. The green pill gives you an 11% chance of living 12 years and an 89% chance of sudden death. And the yellow pill gives you a 10% chance of living a full 18 years before dying with a 90% chance of sudden death. So,
Let's pause here.
of living a full 18 years before dying with a 90% chance of sudden death.
Yeah. What would you choose here?
For this one, I choose the yellow one because it's only like a 1% increase, right? And then the benefits for the like the smaller percentage of living longer are like pretty tangible, right? Compared to 12 years. So I would pick the yellow one.
Okay. We have one yellow. Everyone else?
I'd pick
Uh,
the yellow.
Even I would go with the yellow one.
Same
Yeah.
here.
All right. Everyone's gone with the yellow one. That's cool.
So, which one of these do you choose? So, what did you base your decisions on? Behavioural economists think we make decisions based on something called expected utility. It's how much we expect that something will satisfy our wants and needs. If you like chocolate ice cream more than vanilla, you'll feel more satisfied if you choose chocolate. So for you, chocolate ice cream has more expected utility. Studies show that in the previous question, most people choose the blue pill in the first scenario, giving them a guarantee of living another 12 years, and the yellow pill in the second scenario, giving them a 10%.
So did the behavior that all of us here, right? Did we model the behavior that the person here is talking about? Did we choose the blue pill and then did we choose the yellow pill? Can you guys hear me?
Yeah.
Yeah. So we did model the behavior that she's talking about, right?
Yeah, we did.
Chance of living another 18 years and a 90% chance of death. But what if instead we write out the options like this? Now the options have something in common. In the first scenario, in both cases, you have an 89% chance of living 12 years. So if we remove that, your decision shouldn't change, right? Kind of like how removing a cherry from both ice creams won't change your favorite flavor. In the second scenario, both options have an 89% chance of death in common, so we should just be able to cancel those out too without changing your decision. Hold on, now both scenarios are exactly the same, but studies showed that most people chose the blue pill in the first scenario and the yellow pill in the second one, which doesn't make sense. Both the blue and the green pills give you a higher chance of living over the chance of a longer life. And the red and yellow pills give you a chance of a longer life, but with a drawback of a lower chance of living. So for people who choose the blue and yellow pills, what do they want? A higher chance of living or a longer life? This is called the Allais paradox. It was first outlined by Maurice Allais, a Nobel Prize-winning economist, in a 1953 article. The paradox undermines the theory of expected utility because it shows that we don't always make decisions that align with our wants and needs. We tend to make decisions based on how much we think we have to gain or lose right now, rather than on the final outcome. And we also tend to choose certainty over risk, even if the risky option is the one that's closer to what we really want. Psychologists who have studied the Allais paradox found that people dislike risk in general. When questions are framed in terms of gains or losses, people are far more likely to consider the losses first and try and minimize them. It's a phenomenon called loss aversion. It's similar to regret theory, which says that when we're making decisions, some of us try and minimize the amount of regret that we'll feel.
That's basically the summary. So do you guys realize we did model the behavior that the person here predicted? And
Yeah.
so it's pretty cool, right? And that these paradoxes hold irrespective of who you're asking it to. We're a set of people who come from different countries, we have different backgrounds, and yet we model this behavior. But mathematics and how she's, categorized it using pie charts, that actually says that there's no difference in these choices. But yet we make it because we perceive it in a particular way. Here, the 1% chance of death seems very striking to us. But in the other scenario, that 1% chance of death, the additional 1%, is something we'd like to bet on. And when we talk about loss aversion more, right? Loss aversion is divided into two things: situations where you're risk averse and situations where you're risk seeking. And the theory says that in situations where you're gaining, right? So let's say I'm already holding stocks, or let's take this scenario only. So in situations where you're gaining, you're risk averse to uncertainty. So here I'm risk averse to that 1% sudden chance of death. That becomes more striking to me. And so I want to avoid that risk and I move towards certainty that's there. Right? And this is a situation of strength. It's where I have an option of certainty. So it's a gain situation in that model, right? But in the other scenario, where there's an 89% chance of death and a 90% chance of death, right? In that scenario, I'm at a losing spot. And from a losing point of view, that 1% additional chance of death is something that I'm willing to bet on. And that becomes a risk seeking situation. And you would see loss aversion become very, very apparent in behavioral finance, which is where you talk about stock markets. That you would hold on to stocks that are losing. So if I'm holding like 1,000 shares of Reliance, right? And that stock is a losing stock today. The prices are declining. The prices become very low from when I bought it, right? So in a losing situation, I would hold on to that stock in the hope that it might rise. So I'm in a risk seeking situation because I'm still willing to bet because I'm already losing, right? I might as well try. But in a situation where let's say I bought it at 50 rupees and it's gone up to 100, right? In that scenario, I'm not willing to risk that earning. I want to convert that earning as fast as I can. And in that scenario, I would prefer being risk averse and I would choose certainty over the uncertainty of where the stock markets might go. Right? And this is where you model these behaviors and that sort of thing. We have another paradox here, which is the Ellsbury paradox. This is also something that I'll encourage. So there are a lot of paradoxes. These are two major ones, again, because they were the beginning, right? And what is the situation here? On one hand, you have 10 balls, right? 5 are blue, 5 are red. So you know the quantity of the 2 balls in this bag or in the hand, okay? Then in the other hand, you've been told that you have 10 balls, some are blue, some are red, but you don't know what is the division of blue and red. Now, if I tell you that take out a red ball, which hand would you choose to take out the red ball from?
The right hand.
Okay, everyone else?
Yep, the right hand.
The right hand.
Everyone? Okay. Exactly. All right. you've chosen the right hand. Why did you choose the right hand? Because you were sure that there's a 50% chance of you getting the red ball from the right hand. So you're sure of the probability that's there. Now, if I say that, okay, you've chosen for the red ball, for taking out the red ball, you've chosen the right hand. Now, if I say, now take out a blue ball, you have to take out a blue ball. Now, would you choose the right hand or the left hand?
I would still choose the right hand, I guess. I'd like view it as two independent events. So, like it wouldn't matter. Like, right? Like you're doing it separately. So the probability will still stay the same.
Okay, that's fair. You can assume that. No problem with that assumption. Everyone else?
Yeah, I would also go with the right hand. 50-50% chance. So right hand.
Okay. Do we have anyone else I'm missing? Juan? And I don't know how to pronounce your name. I can only pronounce your surname. Madan? Madan. How to?
I yeah,
Yeah.
Jumna Madan. Yeah.
Jumna.
We like in school now for multiple for true or false, I just put all true because one time will come correct. So I just pick the left hand for both because I'd get a red or blue one in.
So you'll choose the left hand for both.
Yeah.
Okay. Okay. Who else do we have here, Huang?
I'll choose the right hand.
For both the scenarios?
Yes.
Okay. This is great to see. Okay. So we have both right hands and both left hands by Dimna. Okay. What is problematic here? Okay. Let's talk about when you chose the right hand for the red ball. Okay. You know that the probability of choosing the red ball from the right hand is half, right? 50% chance of choosing the red ball from the right hand. Yep. This means that you're also working with an implicit assumption that the left hand would have less than 0.5% of red balls. Just say yes or no if you're following me.
Yeah.
Yeah. So given the first scenario, we're choosing the red ball. My God, choosing the red ball, and the scenario is that when you choose the red ball, the implicit assumption becomes that you're telling me that the probability of choosing the red ball from the left hand is less than 0.5%. Cool. So then, in the first scenario, the probability of choosing blue from the left hand is more than 0.5%. More than 50%. Yeah. Works. If red is less than half, then blue has to be more than half, right? This is our scenario. Okay. Now, when I tell you the second scenario, the number of balls aren't changing, right? If there are 7 red and 3 blue in the left hand, then it remains 7 red and 3 blue when I give you the second scenario as well. Now, when I give you the second scenario, I ask, if I give you the blue ball, which hand will you choose it from? And again, people chose the red hand, the right hand. And so then you're telling me that in the right hand, we already know that the probability of choosing blue is 50%. But if you're choosing the right over the left, then you're also telling me that you think the probability of blue balls in the left hand is less than 0.5%. That is why you'll choose right over left.
Yeah.
Okay. Now, what has happened here? If I compare your decisions in scenario 1 and your decisions in scenario 2, in both situations, you're telling me that the number of red balls and the number of blue balls in the left hand are less than half. Is that possible mathematically?
No, not possible.
No.
Right? If red balls are only 3, less than half, then blue balls have to be 7. Because we already know that the total number of balls are 10. Right?
Yeah.
Now, do you understand how this also reflects that you're always choosing certainty, and when you're aware of probabilities and the outcome that's coming over scenarios where you're not aware of what the probability outcomes or the probability divisions is between the balls. You had 10
I just have
balls.
like, sorry,
Yep.
I just have like a question.
Mhm.
So like basically, I guess what like stopped me from picking the left hand, right, was because we don't know, like, of course, like there's always gonna be like one, like again, like we don't know like the ratio of red to blue in left hand, right? So wouldn't it, I guess like it goes to the conclusion, right? But like, isn't it, I guess, like a logical thing to say like, because if you pick like blue and red, you wouldn't know which one is like 7 and which one is 3, or for example, like no matter like which one you go. So wouldn't it be better to get like a 50-50 than, oh, actually, if you think about it, you could just like say up and down for, there would be like 4 outcomes, right, for left hand, and then there would only be 2 for right hand. So that's like the lesser like risk, I guess, because
So
there's less, yeah.
if someone here would have chosen right hand for first and the left hand for second, or the left hand for first and the right hand for second, that would be consistent in the conclusions that we reach, right? Because what you're doing here is you're contradicting your own assumptions. That's why I said the implicit assumption when you're choosing right over left is the that the left hand has less than half probability for the color you're choosing it for. So then when I ask you the second scenario, your choices should be shifting because you've already made a particular assumption in the decision that you made in the first question.
Oh, okay, I see. Okay.
Yeah. Okay. Okay. Bye, Gia. I'll see you later. So this is exactly why. This is exactly why, right? So there's no problem whether you want to choose right or left. But if you're choosing right for both, and similarly, like Dumna chose left for both, the same problem persists, right? Because how can you choose left for both if you know that the other one has 50-50? So you can choose whatever, but your logics or the implicit assumptions that you're making, they still have to remain consistent with each other. But in this scenario, they're contradicting. And that is why this is a paradox, because everyone here chose that. And so economics is supposed to model behavior, and but doesn't. So that's basically my 2 cents today. It's 10:32, and I would encourage you guys to read up more about the Eli paradox, Ellsberg paradox, if there are other cool paradoxes that you want to know about in economics, right? Test it out. So I'll send you a video, right? And this is something that comes up in behavioral economics again, which is that people have selective focus. Okay, but if I send you the video, you'll know what the video is about before you see the video, so it becomes easier to crack it. Here you didn't know what the paradox is going to be about, so people can't crack what conclusions they should reach. But yeah, pretty cool, right?
Can I ask a question?
Yeah.
So when we talk about reliance, right? And you said, if it's going down, we have a hope that it might go up again, right? But if it's going up, don't we? I mean, humans are greedy, potentially. So can't we also like have a hope? It might keep going up, so people retain it, which is how.
Yeah. So it occurs in both scenarios, right? But there's also this idea. So what you're saying is absolutely valid. But there's also this idea that you don't know, that you want to pocket your profits as soon as you can. So then this is where, in your situation, this is where information and demographics, other factors might come into play. So when I say this is with respect to only how you would perceive it behaviorally, or a psychological view of it, that in gaining situations you're risk averse because you don't want to lose the gains you've made, but in losing situations you're risk seeking because you know that 1% no longer matters, because dude, you're going to die anyway, might as well take that chance. That's essentially what happens, right? But I mean, if you guys want resources, all of this reading is like very cool, because it's very counterintuitive, but if you think about it, you can see other people doing it. Everyone modeled this behavior, and that's so cool to see. That's basically it for today. If there are any questions, I can take that. Otherwise, we can end today's session.
Could I just like ask a question?
Yeah.
So, right, like the paradoxes that we saw were based on like human behavior patterns, right? So well, I guess like firstly, like that could be also like modeled as a probability, right? Like the probability that humans would choose this or this. Personally, like I'm not into economics, but I am into like psychology. So is it kind of like the underlying principle that like economics is like ruled by like rather than like market trends, but like human behavior, right? And like I guess psychological principles rather, and then like that's how the market gets like influenced.
I think what you're saying is how economics is evolving, and that's why there's greater acceptance of the role that psychology can play in economics, right? Because I mean, it doesn't make sense for me to say, you know, when you're reading rational decision theory, that sort of stuff, and you're saying that human beings behave perfectly, you're not accounting for factors. If you're talking about how humans take decisions, you have to account for the psychology of those individuals. And which is why, you know, there's so much behavioral economics today is a buzzword, and this is exactly why, that people are recognizing that you have to accommodate for psychological concepts within economic decision making. And this is why this paradox, and this paradox you can prove it in the probable through probability, right? So the 5 and 5, that's why I said 50% chance of choosing either. So you can use probability to prove the fact that people's decisions are inconsistent in nature. And this is how you're transcending from you know, mathematical economics or economics that's completely set in stone into psychological economics, behavioral economics, and understanding that you have to account for these caveats.
Oh, okay. So like I like I said, like I kind of don't know like a lot about economics in general. So like basically well, like what's happening is that like before it used to be like super mathematical, but now we're introducing like
Yes.
the concepts of probability and stuff.
No,
Okay.
probability has always been there, right? It's just accounting for the fact that there's a behavioral aspect that could contradict mathematical probability. Your decision making in this paradox contradicted the probability.
Oh, okay. So it's kind of like it's the models that they apply to economics are like at like the very basis like built upon probability, but now we're just like considering how I guess like individual differences kind of add to that.
Yes. Yes,
Okay.
exactly.
Sounds good.
All right, great. I think that was a pretty cool session. If you guys want extra resources, right, my number is on the group. So if there's any topic, right, even behavioral economics, that sort of stuff that you want to read up more about and you want good resources, please reach out to me. I would love to share because I'm really passionate about this topic, right? And I hope you found the paradoxes as cool as I do. And I will see you next week on Saturday.
Thank you.
Bye bye.
Bye.
See you.